All right, folks, so today I've got a fun project that is, well, honestly, easy to build. Thought I'd just share it with you guys. We're going to build a really high quality, high power, feature-filled stir plate. And if you 3D print in resin, you'll understand why that's so valuable. Let's get to it. All right, let's dive into this project. So for this project, we're going to need a handful of pretty easy to get a hold of materials. You can substitute some of these out depending on your preferences. But for the frame of this unit, I'm going to be using the 80/20 Systems quick frame. This is a extruded aluminum, very easy to use, and has these nice little corner connectors. So we can build a frame that acts as the enclosure for our stir plate. 80/20 is great stuff. It's really inexpensive. I think we've got $7 worth of extruded aluminum, and the corner pieces are about $2.60 each. If you're looking for part numbers, I believe it is $30.90 for the extruded aluminum that we're using, and it is $91.50 for the corner connectors. Moving on, we're going to be using a 12-volt PC fan. If you can get the kind that have just the 2 leads, that's better than with the 3rd lead, but 3rd lead will cut off. That's for the pulse width modulation and the feedback for monitoring RPMs. We'll be mounting a magnet to this, and that's going to be what actually helps propel our magnetic stir that we're going to be using. Next up, we've got a tub. This one's from OXO Good Grip, and I really like this tub specifically because it is sealable. We're going to be filling this full of isopropyl alcohol so that we can clean our parts that we print and get the resin off. Nice, super easy to use, and it's a lot safer because we don't have all those fumes being exposed all the time either. Moving down, we've got some aluminum sheet. We're using aluminum specifically. We want something non-magnetic. This will create a separation between the stir bar and the bottom of our tub and the parts that we're cleaning. We're going to need a sheet of ABS. You can substitute that out with just about anything you want. Plywood, particle board, acrylic, anything you like. We're going to be laser cutting ours out just so we can match it to the frame quickly, and we've got a laser cutter on standby, but there's nothing wrong with a drill and a jigsaw. Moving on to the brains of the machine. So this is where I wanted to get into some better features. So right now I'm using this cute little stir plate and jar. We got a nice green tint there because we're doing a bunch of castable resins. We'll get into projects with that in the future. But the trick with these little inexpensive stir plates is they're really, really not very powerful. And you really want to get a good vortex in the alcohol as you're washing the parts. This doesn't quite have the oomph to do that. The other thing too about this that kind of is disappointing is it's as dumb as it gets. Literally, it's an on-off switch and that's it. Well, for our project, we're going to be actually using a timer so we can actually set our wash cycle for our parts, as well as a pulse width modulated RPM and power controller for the motor. Now, these are inexpensive parts. You don't have to use these. You can just use a rheostat, kind of like what this has. Costs you $1 or $2 versus $14 for our timer, and another $8 for our pulse width modulated speed controller. And then we're just using a couple little parts for power entry that are easy to install, and a power switch just so we have a master power switch for the whole unit. Very easy to put together, as you'll see here. Let's go ahead and start cutting some aluminum and we can start putting this thing together. Alright, so we're going to start with our 80/20 here. This extruded aluminum is really just wonderful to work with for building just about anything you want. So the way that this stuff works is we're using these corner connectors, and these corner connectors, they really are easy to install. We'll just use a rubber mallet and drive that in. But you can immediately see as we start doing this that we're going to run into a problem where these two tabs interfere with each other. So what we need to do is go ahead and grab ourselves a saw, and we're going to take and bevel this off at a 45-degree angle. That way these parts will all marry together very tightly and we'll get a good joint. So let's get to that. So we've got our parts here, and looks like we've got everything cut just about to length like we needed. And as you can see, if we bring these parts together here, there we go. You can see that our 45-degree angles are going to work just fine for putting this together. All right, before we jump ahead too far, before I forget, so this is a sheet of acrylic. This is an 1/8 of an inch thick. Now, our gap here is closer to 1/4 inch, and we'll be taking and just using some foam tape to seat these panels into our channels here. But we're going to take this sheet of ABS, we're going to throw it in the laser cutter, and we're going to go ahead and just slice that up so that we get our panels. That way, as we put this frame together, we actually have, you know, some wiggle room. One of the things that's nice, this pattern that we're using, we're going to throw up on Thingiverse under the InventGeek account. I think it's thingiverse.com/InventGeek. So you can take and download that, print it out, laser cut it yourself, use a jigsaw, whatever you like. And whatever material you like. So for us, this is what we got laying around, so that's what we're going to use. So we'll fire up the laser cutter. All right, so we've got our laser cut parts ready to go, and these just pop out for us, and you can see that we're going to be using those as we put this together, and we want to lock this into place as we build. So we'll use our rubber mallet, and we'll be able to have this totally put together. The one trick is with our top piece, which is the one that has the holes drilled into it. With our top piece, we're going to be actually mounting that not in the slot, but on top of the channels. That'll seat and nest very nicely, and it gives us the ability to open this up and, you know, do any kind of maintenance stuff we need to without tearing the whole device apart. So, good little trick. All right, so started putting this together. And just, you know, aesthetically, I actually think I really prefer having these on the outside. So what I'll end up doing is using some double-sided sticky tape to mount these. It'll give me a really nice, clean aesthetic at the same time. It'll be just as strong and, you know, capable because, well, we're making the whole thing out of this 80/20. So I think that is the goal. A little design change on the fly, but you know, that's okay. We do that from time to time. So with that in mind, let's go ahead and finish assembling this, and we'll rock and roll to the next step, putting in some electronics. All right, so the next step we're going to do is we're going to prepare our top plate with the fan and the magnetic stirrer. We're going to get this all basically prepped out so that we can just simply connect into our electrical cord here. Now we're going to leave this on just for a brief moment so we can do a little testing as we do our build, and you'll kind of see why that makes sense. So really an easy thing to do here. So we've got our bar magnet. I went with a really large, high-power neodymium magnet that's very long. The reason for that is because then I can accommodate more stir bar options for myself. And, well, I want more power out of this than I have with my little unit, so there you go. So the goal here is we're going to basically be gluing, super gluing, our magnet onto the top of the fan. Trick with that is we need to get this as balanced and centered as possible because we don't want wobble in the machine. That wouldn't be ideal. So to help with that, I've got a little 12-volt power supply, which is what we're going to power this unit with. And what I can do is simply connect that up, and boy, that's about perfect. There's no shimmy or shake whatsoever in that. So got lucky on my first try. You know, I'd rather be lucky than good any day. So I'm going to use a medium strength cyanocryolate, basically super glue. We get this at our hobby stores, and we're going to go ahead and just run a bead right along the sides of the magnet. Not pushing on the magnet so we don't dislodge it. We'll give it a moment or two to wick in, around, and under the magnet. And then what we've got here is some accelerator. This is a catalyst that dries this glue out very, very quickly. And so we're going to go ahead and give it a few spritzes, and looks like my spritzer's about broken, or I'm about out. And this now is more or less ready to go. So the next step in our build for this is going to be mounting it to our top plate. And to do that, it's very simple. We've got some machine screws that we just push through. We've got a couple nylon standoffs. Now, I've got this hopefully set up to where I have just enough clearance. Looks like I can actually probably take out the smaller nylon spacer. And I might be okay with that. So I'm going to go ahead and put this together, and the closer that we have the magnet to the top of the stir plate, the better off we're going to be for, you know, being able to have that, you know, magnet powerfully influence whatever's above it. All right, so let's go ahead and test this out. So we're going to take our power supply and connect it back up. And looks like we're rotating. We don't have any shimmy. That's fantastic. We'll flip it over, and yeah, that's got a lot more oomph than what I had before. This is going to be fantastic. All right, well, let's move on to the timer and the rest of the wiring. All right, so bringing the electronics on this together is really simple. So I'm going to start off by just doing some basic tinning of wires. We actually only have a soldered connection to the switch into our power inlet, but we've got some bridges that we're going to be using, or wires, should I say, between devices. And I'm a big fan of having my wires all tinned up. Makes for a better, stronger connection, safer connection, and makes it actually a lot easier to work with the wire, getting it installed into the socket. You know, it's always funny when I do crap like this on camera, because it is 1,000 times harder to do for some reason on camera than it is in person. Figure that out. I'm going to go ahead and just trim these leads now. Shorten them up to what'll be a little more appropriate so they're not hanging out of that that body of the controller here. Okay, so this wire we just tinned up basically connects this little guy, which is our speed controller, to our timer. And the goal is we've got our stir plate over here, and we have our power inlet here. And so we need to now take our wires for the motor and cut these back so we can solder and tin these as well. So I'm just going to go to work here, and we'll throw a diagram up so you can see exactly what we're doing and how we're doing it. Again, and we're going to go ahead and just drop that right in, and now it'll fit nicely. We can get it to, oop, careful not to pinch our wires. There we go, clip in. Those clips have seated. That'll be a good solid fitting for the future. So for our speed controller, install's pretty easy on this. We've just got a little hex nut here. Okay, just this little hex nut and washer, and we're going to go ahead and slide those off and mount through the hole, and I'm just going to use a socket driver. There we go. Turn that to low. Put our knob where you think it's going to go. There we go. Pretty straightforward. I did notice that this just popped out on me, so I think I'm going to do the fast simple fix, which is a couple drops of our CA glue. Alright, pretty slick. So next we're going to go ahead and mount this, but before I do, just because it'll make my life a lot easier, is I'm going to go ahead and take the wiring from the fan up through the hole. There we go. Go ahead and let that set there, and I'm going to go ahead and connect it to our speed controller poles. Negative, positive, negative, positive, and this is a little bit of a long lead here. I'm going to go ahead and fold that over just so we don't risk it being a problem for us in the future. There we go, seat that right in. Perfect. Alright, so the last step we have is connecting our power source. And so to do that, we're just going to do a quick solder job here and mount the items into these holes, and we are set. Alrighty, so we've got our wiring all done, and boy, this thing actually works really well. So we're going to move on to modifying this little guy, but boy, I'll tell you, good strong magnet. This is going to have tons of torque. It's going to work really well. So the one trick is we just don't want to have any interference magnetically with our stir bar. So what we're going to do is we're going to take our aluminum mesh that we've got here, and we're going to cut it to be the same diameter as the bottom of our bucket here. Pretty simple process. We're going to use a little bit of aluminum for some standoffs, and yeah, pretty easy. Let's just do that real fast, and then we can see this thing run. All right, real simple. We're going to take and throw our bucket on, go around it with a Sharpie. Make sure we get the table. We're going to use a giant pair of shears. These things are huge. And we're going to go just slightly in from the cut we made so that we know we've got something that'll fit on the inside diameter. Now, a good friend of mine, Max, probably would be scolding me right now because, well, safety third. And I have not got my protective gloves on. That stuff gets real sharp, so be careful. And, oh, look at that. Perfect. That's exactly what we're looking for. Nice fit. Okay, so now we just need to add some feet to this. So what I've used is a little prop spinner. This goes on the shaft of a motor and holds a propeller for RC airplanes. And it turns out that they're just about perfect for what I'm looking for here. In having some feet to hold this up off the bottom of the bucket. So again, they're aluminum, so they're non-magnetic and they won't interfere. Kind of fun. So let's go ahead and let's kind of put this thing together, get it ready to go. So first things first, we're going to put our container on top. There we go. With our stir bar in the bottom, and we're gonna set that mesh down. As you can see, there's clearance there, so we shouldn't have any problems. Next, boy oh boy, I'm gonna go through some isopropyl here, and let's fill this thing up. Okay, I am ready to see this thing in action. So we're going to go ahead and turn this thing on. Get our stir bar up to speed. And that is working absolutely fantastically. This is going to work out real well. All right, so here we have it. Our stir plate and our part washer are complete. I gotta be honest, I'm very happy with how this came out. This is as good or better than many of the other stir plates that I've seen out there. Now, of course, it's not heated, but we don't need heat. We're playing with volatile, liquids. But all in all, I mean, we're really talking about a very affordable build. This is the kind of thing that you could do in a weekend, and boy, I'll tell you, you want to talk about quality of life when it comes to 3D printing with resin, this makes all the difference. Absolute game changer. Makes cleanups easier, makes getting the parts finished easier. It's just a great way to take care of your 3D prints, and I couldn't be happier with how it turned out. So there you have it. First in a line of projects on 3D printing. And again, this is a project that anyone can do on a weekend, very small budget, and you really walk away with a fantastic end result. So we hope you enjoyed this, and we've got more 3D printer projects coming. Stay tuned for those, and until then, keep making.